Today's lesson is on solving equations, and we're going to break this up over a couple different days. We're still in our Algebra Skills Review unit. So the first kind of equation that we already know how to solve is linear, and everybody loves linear. When we solve linear equations, we want to isolate the variable, and an example of this would be if I had, say, 2x minus 7 equals 12. I would add 7 to both sides, get 2x is equal to 19, and then divide out the 2, and then get x is equal to 19 seconds. Those are pretty straightforward. We've been solving linear equations since we were in middle school. Okay, moving on, in Algebra 1 we learned how to solve quadratics. And when we're solving quadratics right now, we're only going to be looking for real solutions. Well, there's more or less 3 approaches when we have a quadratic, and it just depends on the equation. So the first one is going to be we can factor it if it's factorable. Remember that when we solve by factoring, we always need to set the equation into its standard form and then set it equal to 0. And of course, when we're talking about standard form, we're talking about ax squared plus bx plus c equals 0. And then again, we factor if it's factorable, and then by the zero product property, then we solve for x off of each factor. The next way is to undo or extract the root. And this more or less is a reverse order of operation. So remember, our order of operation is please excuse my dear Aunt Sally, or PEMDAS. And so what happens then is we add and subtract first, and then we multiply or divide, and then we do exponents and parentheses. And again, we're working backwards for this. Right, and an example would be if I had 4 times, let's do x minus 3 quantity squared. Let's set that equal to, say, 16. So there's no adding or subtracting step. Next, we would do the multiplying and dividing. So I would divide each side by the 4. So then I'd get x minus 3 quantity squared equals 4. Square root both sides. Right, to undo the root, square root both sides. And then I would get x minus 3 is equal to positive or negative 2, and then I would solve each. And then I would get 5 or 1 for my 2 solutions. And then the last technique, of course, is the quadratic formula. And when you have the quadratic formula, you need to make sure, again, that the equation is set into standard form before you pick off the variable or the values for a, b, and c. And remember, our quadratic formula is x is equal to negative b plus or minus the square roots of b squared minus 4a times c all over 2a. And remember, to have a real solution, that means that the discriminant, and this is the discriminant, the inside part of the radical, must be positive or 0. If that quantity is negative, then there are no real solutions. And again, b squared minus 4ac is called the discriminant. Last technique for quadratics is we complete the square. And when you complete the square, there's 2 issues with this. When you complete the square, first, the leading coefficient for x squared must be 1. If it's not, then you're going to have to do some factoring or some dividing out. And then the second issue is you have to figure out what is going to be the value to create a perfect square trinomial. And the special number that we find is b over 2. And then we square it, and then we add that to both sides. and then that creates the perfect square trinomial. And so then once we factor the perfect square trinomial, then we get the quantity x minus a quantity squared, and then we can extract the root from both sides. And we'll practice this below. Looking at example I here, number 1, notice that the coefficient of x squared is already 1, and so I don't need to do an additional step there. That's the first thing that I check. And then the second thing I do is I get ready to complete the square. And so I take my constant and I move it to the right-handed side. So it's going to give me x squared minus 8x, and then I'm going to add some number that I'm going to find in just a second. So I put in a blank, is equal to -5, and then I have to add the same number on the right-handed side as well. Now I'm ready to figure out what is the special number that I need to make this turn into a perfect square. So we do b, which is -8 over 2, and I square that. And of course, that's going to give me 16. So I have to add 16 on the left-handed side and add 16 on the right-handed side. Now the left side is now a perfect square. It's x minus 4 quantity squared, and the right-handed side subs to 11. And now I'm ready to finish it off. Square root both sides, and I have x minus 4 is equal to plus or minus square roots of 11. And then x is equal to 4 plus or minus the square roots of 11. And that's my final answer here. Now pay attention that inside your radical, you can't factor that into a perfect square factor, because if you can, you do need to simplify this. So your answers must be reduced So remember, we call this SRF, simplified radical form, and we won't be using decimals. And that means then that we're giving exact answers, and so that would be the answer that I want. If you want to separate it into 4 plus root 11 and then 4 minus root 11, that's perfectly fine, but I personally don't prefer that because that was the whole point of creating that plus minus symbol. Now let's consider the second example here, double I, number 2. And notice for this one, I've got a coefficient that is not 1. Well, I'm going to go ahead and get ready to complete my square. And so I'm going to take the positive 1 and move it to the right-handed side. Now what's going to happen is on the left-handed side, I'm going to factor off this 4. And so I'm going to get 4 and then parentheses x squared plus 2x plus, now here I'm setting up my special number that I'm going to find. And then on the right-handed side, I have to add whatever I add on to the left. Well, whatever you add on to the left has the scalar of 4 on it. So remember, the 4 I factored off of the x squared term, and the 4 I factored off the middle term here, and so the resulting factor is 2x. And so this 4 is also going to be on this constant. So what you have to do then is you have to account for that when you add the quantity to both sides. All right, now figure out your special number. So off to the side here, I've got b over 2. So again, my b is 2. So I've got 2 over 2, and then I square that, and of course that's just going to give me 1. Well, remember, it's not really 1, it's 4 times 1. And so you're really adding 4 to both sides. Now the left-handed side becomes 4 times x plus 1 quantity squared. And then the right-handed side is 3. I divided out my 4, and so I get x plus 1 quantity squared is equal to 3/4. And then I go ahead and I square root both sides. And so then I get x plus 1 is equal to plus or minus the square roots of 3 over 2. Subtract the 1, and I get -1 plus or minus the square roots of 3 over 2. Now, if you wanted to join this together into one fraction, your first term here, we need to put that so that it's over a denominator of 2. And so would need to introduce 2 onto that. So the other version for this would be x is equal to -2 plus or minus the square roots of 3 all over 2. And for me, it doesn't matter which one you want to use. Either one is perfectly fine for me. You might want to just double check with your teacher what they prefer. All right, the last kind of solving today is going to be a rational equation. And here what we're going to do is we're going to multiply each term by the LCD to clear out the denominator. Now remember, when I was simply adding and subtracting rational expressions, the denominator did not disappear. But now the difference is I'm solving an equation, and now I can eliminate the denominator each time. Example A here, this isn't really a rational, but it's okay. It just gives us the idea of what we're trying to do here. Off to the side, I like to jot down what my LCD is. And so in this case, 5 and 2, the least common multiple is 10. So then what happens is I'm going to multiply 10, and really it's like 10 over 1, but we just write it as 10. And I'm going to multiply that onto each term of my equation. So you've got 3 terms. I've got my first one, my second one, and then over here on the right-handed side. So then for my first one, x over 5 times 10, well, that reduces to 2x. And then my second fraction, x over 2, well, x over 2 times 10, that's going to reduce to 5x. And then 3 times 10 is 30. So then I have negative 3x is equal to 30, and x is equal to negative 10 for my final answer. Now, if you're kind of having some trouble recalling, what I'm doing here, what I'm doing in my mind is I'm doing x over 5 times 10. And so that gives me 10x over 5. And of course, 5 divides into 10 2 times, so I'm getting 2x from that. And obviously that's what I did on both fractions then in my mind. And if you need to write that off to the side, that's perfectly fine to do so. All right, looking at example B here, I've got 3 over n plus 2 is equal to 12 over n plus 2. Now this one is a little bit different than the last one. The variables are in the denominator, but notice that there's one fraction on the left side and only one single fraction on the right-handed side. So this is actually a proportion. Proportions can always be solved using cross products. Right, so here I would get 12 times quantity n plus 2, and then is equal to 3n plus 2. Well, now what? Now I need to go ahead, distribute, collect like terms, and set the equation equal to 0. So left-handed side, notice I have 12n plus 24. Right-handed side, 3n squared plus 6n. Setting the equation equal to 0, notice that I would get 3n squared minus 6n minus 24 equals 0. Next, I divide out my 3, and I get n squared minus 2n minus 8 equals 0. Notice that I have a quadratic. All quadratics can be solved by either factoring or the quadratic formula. We always want to factor if it's possible because it makes the solving much quicker. So notice that I have n minus 4 and n plus 2. And again, make sure that you double check your middle terms. So 2 times n and negative 4 times n, yes, that will sum to negative 2, so I'm good there. And then I get n is equal to 4 or n is equal to negative 2. Now, you have to make sure that you check your answers. And notice that when I check my answer, I can already see right away on my original problem, if I put negative 2 into either denominator here, I'm going to get 0 in the denominator, and remember that's the definition of undefined. So -2 is not a solution, so the only solution here is for 4. So the rationals do require you to check. You can check off to the side, or sometimes you'll be able just to kind of use your eyes and quickly decide if that is a solution or not. All right, looking at example C, 1 over x minus 2 plus 3 over x plus 3 is equal to 4 over x squared plus x minus 6. Well, my denominator on the right-handed side, notice, is x plus 3 in its factored form and x minus 2. And so the least common denominator here is going to be one of each of those. All right, so now I'm going to go ahead and start off by multiplying the entire equation by x plus 3, x minus 2, and this will clear out my denominator. So make sure that you understand you're taking these factors and you're multiplying by each term of the equation. So my first term, the x minus 2's divide out, so I'm left with x plus 3. And then on my second fraction here, the x plus 3's divide out, and I'm left with 3 times x minus 2. And then the right-handed side, both factors divide out, and so I'm just left with 4. Again, collecting like terms and regrouping, notice that we get 4x minus 3 is equal to 4. Then I get 4x is equal to 7. And x is equal to 7/4. And I can tell right away that this is going to check out, okay? So make sure that you check your answer. And again, when I substitute 7/4 into my original problem here, none of the denominators are going to turn to 0, so I know that I'm good to go. All right, example D, 3 over x plus 1 plus 7 over x plus 1 is equal to 3 over x. Okay, notice off to the side here, I've got x, and then x plus 1 is going to be my least common denominator. So I'm going to multiply through by that. And again, remember that you're multiplying each term of the equation by that product. Well, on my first fraction here, everything is going to divide out, so I'm just going to be left with the 3. On my second fraction here, the x plus 1's divide out, so I'm left with 7 times x. And then on the right-handed side of my equation, the x's divide out, and I'm left with 3 on x plus 1. So then notice I have 3 plus 7x is equal to 3x plus 3. And then I get 4x is equal to 0, and x is equal to 0. Okay, again, make sure that you check your answers. And right away I can see when I substitute 0 in here, that makes my equation not defined. So here there is actually no solution. This is a failure. You've only got the one value to check, and it does not check. So this one is a no solution variety. All right, that concludes the lesson for day 1 for our solving. Make sure that you run through and do your homework out of your homework packet for solving equations day 1, and then we'll proceed onward tomorrow with some more examples of solving.